Okay, so we've just hit a minute. So first of all, welcome everybody for joining. My name is Lisa Sercombe, if you don't already know. I am a product manager here at Millennium Science, and I wear a few caps here, which will be highlighted in our presentation. I'm the product manager for Agilent Biotech Instruments for the liquid handling and detection. And also I'm the newly appointed ELISA product manager as well. So this is a very apt presentation, which is basically going to discuss the ELISA best practices and troubleshooting, or colloquially, as I was putting it, the ELISA tips and tricks. So just a really quick outline on today's presentation. I'm just going to give some background, some benefits of ELISAs, the types, the tips and tricks, and I'm going to gear those towards really the devices, the washing, and have those as really specific tips and tricks available for you. Also the suppliers, because it's not just instruments, as I mentioned, we do look after ELISA suppliers as well. A summary and a surprise. I did hint this in a email campaign that I had provided. So I do recommend watching until the end because we have some really interesting surprises to share, and I can't wait to share those with you. So first and foremost, ELISA, how does it work? Well, there's several techniques when it comes to detecting different analytes, but essentially the building blocks are the same. You'll have an antibody, an antigen, a conjugate, which will have typically an enzyme added to it, and your substrate, which can change color. And there's many different ways in which you can run an ELISA, the most common of which is on a microplate. And I'm just going to go through this here. I've tried for consistency to keep the colors similar so that this is fairly easy to follow along. So you can have, in this instance, an antibody attached and conjugated to the plate. You have your analyte of interest being bound, your antibodies of interest and your conjugate, and a substrate allowing for a colored base change, which you can then visualize. And this colored change can be both absorbance and fluorescence based. And there are several benefits of ELISAs. Sensitivity is a key one because you're using an antibody. This is very specific, and this is important when you're looking at rare analytes as well, because you're having a series of wash steps to remove any unbound material. And they are also very reliable. The antibody and your analyte are very tightly bound and with wash steps as well. Affordability, ELISAs are fairly routine and inexpensive, which is fantastic for the lab. It's a routine process, and through using microplates, you can actually increase the throughput of your assays along with automating them. So you can have a very quick assay and a quick turnaround. They're also very easy to learn and use. You also can get two kind of results from an ELISA, quantitative and qualitative results. When it comes to the types of ELISAs, there's a few of them. You have direct, these are typically the most common, but this is where you have your analyte of interest directly bound to the plate. We have your indirect here, where you have your analyte and then a second antibody with a substrate conjugate attached. Our sandwich, we find, needs to be the most common, where your one antibody that is detecting is not labeled, but you'll have a secondary antibody with a label conjugated. And the sandwich is really advantageous because the process is very similar. So when you're looking at multiple analytes, a sandwich ELISA is very advantageous. Your competitive is where your analyte is typically conjugated to an enzyme, and this competes with your experimental standard samples for binding sites on the antibody. And unlike the ones that I'd spoken about previously, when it comes to competitive, your signal is actually indirectly proportional to your sample. So that being said, the brighter or the sample, the less concentration of your analyte, and so on and so forth. Lastly, we have your kinetic, which is essentially an unstopped ELISA, where you're monitoring a color change over time. When it comes to the results of your ELISAs, you can generate both qualitative and quantitative results. Your qualitative can be your control well, or even a positive and negative result. This is important, for example, if you're detecting a virus, or if you want a yes/no result. And then you have your quantitative using a standard curve of known concentrations, and then generating the concentrations of your samples using that standard curve. And when it comes to detection, I did touch on this briefly. There are two main detection types for ELISAs. You can do absorbance or fluorescence-based ELISAs. Absorbance, for the most part, are the most common. And this, with an absorbance, you're determining the concentration of your analyte, and this will absorb light at a specific wavelength based on Beer's law. So the path length of the analyte, or the absorbing material, is proportional to the optical density returned. There are several substrates that you can use in absorbance detection. Horseradish peroxidase is by far the most common, and within that, TMB is the most common. You also have alkaline phosphatase, beta-galactase, and urase. Something to note is that the wavelengths for all of these substrates are very specific, but when adding a acid stop, this can actually change the absorbance wavelength for all of these substrates. So it is important to note what these wavelengths are and whether adding an acid will change them. And an example here is TMB, which I mentioned is the most common for the HRP. So on its own, it's 650, but adding an acid stop, it becomes 450 nanometers. Moving on to fluorescence. And so fluorescence detection has a few advantages. Sensitivity and linear range is a prime example of that. Through exciting a light, the energy of the fluorophore itself gains energy, and then it dissipates it, and the resulting energy is typically emitted at a lower energy level, and you can detect all of this. The advantage of fluorescence is that you can detect multiple sample analytes simultaneously. You can see here from the image on the left screen, here there are two actual fluorescence moieties here, and they have distinct fluorescence excitation and emission, which you can capture. And looking at an instrument, you can use both fluorescence or monochromators to analyze and detect these information. When it comes to detection and conjugates, they're fairly similar to your absorbance. You can use alkaline phosphatase, horseradish peroxidase, and beta-galactase. When it comes to your tips and tricks, as I mentioned, I'm going to target these towards the ELISA devices, just to give you some very specific information. But I wanted to also touch on the ELISA devices as well, because we are only so good as the tools that we use. So when it comes to microplates themselves are really the cornerstone of ELISAs themselves, but there are other alternatives you can use. A tube is an example. The advantage of a microplate, well, there are a few. For example, there are multiple densities in which you can utilize for your ELISAs to allow you to increase your throughput. They are standardized as well. So the plate will be the same size irrespective of your density. It's just the sizing between the wells will be a bit smaller. And because this overall dimensions is the same, this really is exceptionally handy when it comes to automation. Some tips when it comes to your microplates. There are a few here, and I will just touch on a number of these. First and foremost, microplates, when it comes to your ELISAs, you may not be using an entire microplate. You could be using strips, and it's important that these strips are evenly seated in the plate themselves. Any bowing of them, or if they are not level, can lead to not only poor washing, but you could be hitting the bottom of the wells themselves. Another one, if you are not using all of your wells, it's important to keep these stored in a sealed pouch with the desiccant, just to remove any unwanted moisture. When you're going to detect your microplates, it's important that the bottom surface of the plate itself is clean. If, for instance, you're not using gloves, we want to avoid fingerprints as well. So when you are going towards detecting your plate, it's just good practice to wipe the bottom of the plate itself with a lint-free cloth. Another thing that you want to make sure is not to allow your wells to become dry once the assay has begun. Next, pipettes. Pipettes are a key fixture when it comes to your ELISAs. You have multiple options as to how you would like to add your reagents to your microplates. You could use single channel, multi-channel, and there's fully automated and semi-automated systems. I won't touch too much on these, but something that really is important is that your pipettes are calibrated and accurate, because this can impact your results. And that's essentially, for the most part, what these tips are all about, making sure that they're calibrated regularly according to your manufacturer's instructions. Also, avoid touching the side of the well with your tips. You want to make sure that all of your samples are in the well and being mixed continuously. Avoid blowing out any of your tip contents, otherwise you may create bubbles. Lastly, we want to make sure that the pipette barrel is free of residual fluid or dried material. And this can be as a result of contamination, and this may not affect your results perhaps today, but going forward it absolutely can. But also this can affect the calibration of your actual pipette itself, and again can affect your ELISAs going forward, so reliability. Washes themselves, and this is something that biotech actually do manufacture themselves. So as the product manager for the Agilent Biotech instruments and my area, I do have a few things that I can comment here. We have our manual systems, but we do, when it comes to the washers, have semi-automatic systems. We have our strip washers here. The 50TS, as visualized on the screen, is a prime example of this. An incredibly handy instrument, especially if you're not washing full microplates and strips themselves. It's a fantastic instrument, and you can adjust the manifolds depending upon how you want to wash the plate. There are options there. We do have the full plate washers, the 405TS, and this is a personal favorite of mine. It is a 96-pin washer. You can wash all of your wells simultaneously. It also has the option to have ultrasonic advantage. It allows for automated washing and consistency, and that's one of my prime favorites. So I will mention that right now, and I can't help myself because I do really appreciate this feature when it comes to consistency. And lastly, we do have fully automated systems. We have seen with the image just here, it's called the EL406. So not only will this allow you to wash your system, but is an automated dispenser. So you really can provide a full ELISA workstation with this instrument itself. It's incredibly fantastic, compact system. Going into some of these features, an example with the 50TS, with all of our washers in high functionality, we've got ease of use and speeds as an example, and depending upon your needs themselves. With the strip, speeds may not be quite as fast, but if you are looking for just a single strip, there are ways that you can adjust that as necessarily. The 50TS has great flexibility from 24 or 96 and 384. All of them are touchscreen, and we have additional functionalities, automatic buffer switching should you need them, along with, if you're not using a traditional microplate based assays, if you're wanting to use any bead or biomagnetic separation and vacuum filtration, these options are available with the 50TS, along with as well the 405 and the EL406. When it comes to some tips for the washing, again, there are quite a few here. I'm just going to touch on a few briefly. First, when it comes to your washing buffer, it's very simple, but it must be said, please follow the recipe to the letter. It's going to make sure that everything is being washed as necessary. It's also important to check the alignment daily of your washer if you're using one. The advantage of the biotech washers is that they actually have a startup routine where they do all of these checks for you, and so it's incredibly helpful. You want to make sure your plate is leveled, so not just even if it's the strips, same leveled, also the microplate itself. Another thing, many people like to make sure that they are blotting and inverting the microplate to remove any excess liquid. Ensure to do that, but make sure that your plate does not completely dry. Do not allow your wells to completely overflow, as this can lead to cross-contamination. Be certain to wash your plate a specified number of times. If your commercial kit, the one that you're using, says wash 3 times, it's recommended to wash those 3 times. Now, obviously, washing is a key step, but also is detecting where you're getting your data themselves. And there are multiple approaches that you can use to get your results. You have manual systems where you're reading one row or well at a time, semi-automated systems where you're reading one plate at a time. And especially when it comes to ELISAs with high throughput, you can use fully automated systems. And you see a key example here on the screen, having a robotic arm. This is the biostack conjugated to a reader itself. And this will allow you to process multiple plates at one time. And with the biostack, you can do that for 10, 30, 50 plates. Some key features of the biotech instruments, I'm just providing the 800TS as an example. Linearity, and this is incredibly important because it allows you to measure your absorbance values at a broad range, and they will still continue to be linear. When this comes to your high concentration values, it's still going to be linear, and this means that you don't need to dilute your samples. Repeatability, high quality parts. The 800TS, you can actually will read your wells 8 times. You are going to have incredibly accurate data. Ease of use, convenience, it's incredibly an intuitive system, especially with the touchscreen itself. Speed and functionality. And here's an example of this table here with speed. We have multiple different options of how you want to read your results. The normal, as I mentioned, giving you exceptionally accurate results of reading a well 8 times. You can read a plate in 39 seconds. Now, for instance, if you are looking at qualitative data where you just need a simple yes or no, there are options for a rapid or a sweep mode. where you can read a plate as quick as 18 seconds. So really, there's options to cater to whatever you should need. And software, this is something that I definitely wanted to touch on. In my experience in my PhD, I was not fortunate enough to use the Gen 5 software, and I'm still a little bit bitter about it, to be honest. I love the Gen 5 software. It allows you to use your reader control, your data reduction, import data, export data, instrument control internally, but also externally to the PC. All of it in one convenient software. It's in stepwise, it's incredibly logical. And I just like that you can build everything you need in one protocol, press play, and this will allow you to consistently perform and utilize the instrument, but also post data reduction of the data itself, as compared to taking that out into Excel. And if you're not doing a assay consistently, which I sometimes could happen, and trying to remember how I did it the last time. Some other little tips I want to provide, some time and temperature. So ELISA kits for the most part are going to be stored potentially frozen or even at 4 degrees. So it's important that we bring the reagents to temperature and the microplate before use. And the reason being is that the reagents themselves are incredibly temperature sensitive. Having a lower temperature can decrease your OD values. Having a higher temperature can increase your OD values. And it's not just the temperature itself of the reagents. Lab temperatures can affect this as well. So you just want to have a calibrated thermometer to take this into account. Along with the draft or even fans in an incubator is something to consider, because evaporation can cause an edge effect. One thing that I didn't think of, and I wish I did in my PhD, something we take for granted, is your timers. They're not always going to be accurate over time as the batteries die. So periodically check them, replace them, and make sure that they're working to your efficiency. Small things like this can affect your consistency. And lastly, make sure you're reading your plate within the specified time limits of adding your stop solution. The reason being is that stop solutions are often acidic, and long exposure to these acids can lead to the degradation of your absorbance material. Substrate preparation, especially if you're using a 2-reagent system, please make sure that they are freshly prepared on the day and you're using them within an hour. We don't want to be having them on the bench for extended periods of time. Again, temperature is important, as this can affect the rate of the color reaction. Always use a fresh bottle for substrate. Do not combine old with new, and it's always best to discard your old bottles. When it comes to conjugates, please store as directed. Conjugates often are the one component of a kit that have a separate storage than the rest of it. So if it needs to be stored separately, please do that. Make sure you're not storing it diluted, and only make the conjugate up as you need it. When it's coming to adding your samples, I did mention this a little bit earlier with pipettes, but yes, please make sure that you're having the adequate mixing of your sample and your buffer. It's not being left on the side of the wall, because again, this can affect the consistency of your results. For stopping reagents, there are quite a few. I'm just going to point out 2. First of all, make sure you know the appropriate time of your stopping reagent. Many kits will say this, so please follow those instructions. You want to make sure that the enzyme substrate product is in the linear phase. And again, if the stopping reagent is going to affect the absorbance peak of your substrate, please make sure that this is known. And adjust your protocol accordingly. As I mentioned, I'm not just the product manager when it comes to the instrumentation for the ELISA workflow. I am the newly appointed ELISA product manager as well. I do wear many hats here at Millennium Science and Jomar Life Research. And I just wanted to highlight a few of our top suppliers that we provide: Ray Biotech, Cloud Clone, eLab Science, Kusabio, MyBiosource. And in the middle, most recently, we also have the Abacan ELISA kits as well. Just want to give a really quick summary, and the surprise is imminent. So hopefully you guys can bear with me, and I will be announcing this very shortly. So as I said, ELISA is a technique that uses antibody specificity, and you can use it to quantify a diverse range of analytes. Because, and despite of this diversity, the process is pretty stock standard. So this is fantastic when it comes to automation. The automation needs to be functional, easy to use, rapid and affordable. And I mean, whilst I'm talking about this right now, that's where biotech comes in, and they are incredibly fantastic instruments. I could not speak highly of them. I have discussed several do's and don'ts when it comes to using and storing ELISA reagents. If you do have questions, do let me know. But for the most part, ELISA reactions are generally very easy to run. I do have some troubleshooting suggestions. For the sake of time, I could not go through all of those today, but if you would like this information, I do have them and I can share them to you. So feel free to send me an email, leave a comment, whatnot, or get in touch. Happy to help. Now we have our surprise. End of financial years. Well, I mean, it's a little, everyone's doing it. I wanted to rename it a little bit and call it Lisa's Loves. These are things that I am passionate about. And also with science, we do tend to name things after ourselves. So why not? That's what I'm doing at this time for our promotions. And we have, as you can see here on the screen, not one or two, we have 4 different promotions that we are providing at the moment. First of which, if these look familiar, they should. I have been discussing it. We have a bundle offer for the 50 TS and the 800 TS. We find these are incredibly popular, and this bundle is backed by popular demand, especially for our ELISA workflow labs. So if you are ELISAs, or if you just want to add to become the ELISA champion of your lab, even if it is self-titled, this is a fantastic bundle for you. Pricing wise, it's about I think 12,000, a little bit around that. Off the top of my head. It's a fantastic bundle, and if you would like further information or pricing, please let us know. Next, one that I'm exceptionally excited for is the Synergy HTX. This is our tried and true workhorse, amazing instrument, super flexible. It does your absorbance, your fluorescence, your luminescence. So if you're not just doing absorbance-based ELISAs, you're also doing fluorescence, or even future-proofing your lab, the Synergy HTX is a fantastic instrument, super flexible, and this is a one-time only. This never ever goes on sale, and we are having a 15% off for the next end of financial year for the Synergy HTX. So I'm very happy and excited, if you can't already tell, to announce this promotion. But it's not just the instruments themselves. As I said, multiple hats. We do have some reagent promotions coming through, one of which is eLab Science. So eLab Science is one of our, as I mentioned, our ELISA suppliers, and we are having a 30% off all of their ELISA kits for the next 2 months. And not to be outdone, we also have Cloud Clone. So Cloud Clone, as I said, is another of our top suppliers. They have a wide range of species and targets for their kits. And they are also, and we are also having a 30% off all Cloud Clone kits. So there is a bit of information here, but all of which are exceptionally exciting. And I am So glad to be able to share all of this with you. Lastly, thank you so much everyone for joining us today. I realize everyone is busy, so I'm appreciative of all of you taking the time to listen to everything we have discussed today. Please let me know if you have any questions. We do have a chat box which you can answer here, or if you do have any questions, feel free to get in contact. My email is not on the screen, but I do believe most people have my emails, or you can get in contact with us through our websites.